Hi, hello friends. Welcome back to Chindu Smart Class. In this session, we are going to discuss about inverses. In modular arithmetic, generally we need to find inverse of a number with respect to an operation. Here, we need to find the inverse of a number for two operations, addition and multiplication. The inverse of addition operation is called additive inverse. The inverse of multiplication operation is called multiplicative inverse. First discuss about additive inverse. Additive inverse. Additive inverse means there are two values a and b, a plus b, which is congruent to 0 when you perform mod n, then these two values are additive inverses to each other. Okay, so a is additive inverse to b is additive inverse to a. Okay, so we need to take Zn. What is Zn? Zn means it is a set of values. It is a set of values like 0, 1, 2 and so on, n minus 1. That is Zn. Set of, we call it as set of residues or set of values 0, 1, 2 and so on, n minus 1. That is Zn. And what is this one? This is an operator. We use this operator for modulus operation. We use this operator for modulus operation. For example, 23 mod 10. What is this value? 23 mod 10? 3. We will get 3, which is congruent to 3. 23 mod 10 is congruent to 3. At the same time, 13 mod 10, it is also 3, which is congruent to 3. For two different values, okay, 23 and 13, for two different input values, same modulus value, we get the same output. Okay, so that's why we use congruence. This is called congruence operator. This is called congruence operator. We use this operator for only modulus operation. So here a plus b. If a plus b is congruent to 0 mod n, then it is called additive inverses of each other. A is additive inverse to b and b is additive inverse to a. What is n? That is Zn. Zn, set of values. Zn means it is a set of residues or set of values 0, 1, 2 and so on, n minus 1. We need to take a value from n. We need to take a value from n, and at the same time you need to find the additive inverse. Okay, so suppose if the input is a, then you need to find the additive inverse b. If input is b, then you need to find the additive inverse a. So how can you say these two are additive inverses to each other? A plus b, which is equal to 0 mod n, then that means both are additive inverses to each other. Okay, in modular arithmetic, each and every integer Zn is equal to 0, 1, 2, 3 and so on, n minus 1. Okay, in this set of values except 0, all the values contain additive inverses. All the values contain additive inverses. So here the sum of integer and It's additive inverse. So the sum of integer and its additive inverse is congruent to 0, then it is additive inverse of a number. B is additive inverse of A. So for example, if you take Z10, in Z10 which values additive inverses? 1, 2, 3, 4 and so on, 5, 6, 7, 8, 9. Okay, all the values except 0 contain additive inverses. Suppose according to this formula 1, if you take 1 plus which value is equal to 0, mod n. If you put 1 plus 9, 1 plus 9, 10. 10 mod 10 is equal to 0. You can take 0 also, no problem. 0 plus 0 is equal to 0, no problem. You can take 0 also. 0 plus 0 is equal to 0. Okay, so the pairs are 0, 0, 1, 9 and 2, 8, 3, 7, 4, 6, 5, 5 and 6, 4, 7, 3, 8, 2, 9, 1. 9, 1 which is same, 1, 9. 9 is additive inverse to 1 and 1 is additive inverse to 9. And same 8, 2, 7, 4, 7, 3, 6, 4. No need to write all these values because we already have written here 1, 9, 2, 8, 3, 7, 4, 6. Okay, if you observe this one, each integer has a unique additive inverse value. For 1, 9, 1, 9. For 2, additive inverse is 8. For 3, 7. For 4, 6. For 5, 5. Okay, if you observe that each value contains a unique value, a unique additive inverse value. Okay, all those are different values. This is additive inverse. And coming to multiplicative inverse. Multiplicative inverse. Okay, here if you take A and B, how can you say A and B are multiplicative inverse of each other? Here the formula is A into B, which is congruent to 1 mod n. In additive inverse, A plus B is congruent to 0. Here A into B is congruent to 1 mod n. Okay, suppose for example if you take the modulus value, what is the multiplicative inverse of 3? 3 into some value must congruent to 1 mod 10. So which value we can write? 3 into 7. 3 into 7, 21. 21 mod 10, which is equal to 1. That means 7 is multiplicative inverse to 3 and 3 is multiplicative inverse to 7. 3 and 7 both are multiplicative inverses to each other. So here if you take Zn, okay, Zn means 0, 1, 2 and so on, n minus 1. If you take Zn, the integer from set may or may not contain multiplicative inverse. Like I said, in additive inverse, each and every value has additive inverse. Whatever the values in the set, all those values have additive inverses. But it is not like additive inverse. It is different from additive inverse. Here, the value may or may not contain multiplicative inverse. How can you find whether it is having multiplicative inverse or not? If it has multiplicative inverse, that means the integer and its multiplicative inverse is congruent to 1. Okay, so using this one, we can say that this value contains multiplicative inverse. It can be proved that a simple solution A has a multiplicative inverse in Zn. When A has multiplicative inverse in Zn, if and only if GCD of n comma A has multiplicative inverse in Zn. If and only if GCD of n comma A is equal to 1. Okay, how can you say that A has multiplicative inverse? If GCD of n, if GCD of n and A is equal to 1, then we can say that A has multiplicative inverse. We can say A has multiplicative inverse. As I said before, if GCD is 1, that means both values are co-prime to each other or relatively prime to each other. So here n and A both are relatively prime to each other or co-prime to each other. What is that value? So if you want to find the multiplicative inverse, you need to follow extended Euclidean algorithm. Whether the value is having multiplicative inverse or not. Using this one, GCD of n comma A is equal to 1, then that means it has multiplicative inverse. Then what is that multiplicative inverse value? If you want to find the multiplicative inverse value, then you need to follow extended Euclidean algorithm. So in the last session, we already discussed extended Euclidean algorithm. You can follow that one. Suppose if you take Z10, what are the values contain multiplicative inverses? What are the pairs? If you take 1 and 1, GCD or 1 into 1 is equal to 1. Okay, when mod 10. So it is one pair. So 1 has multiplicative inverse, and next 3 comma 7, 3 into 7, which is equal to 1 mod 10. So 3 has multiplicative inverse. So 3 and 7 both are multiplicative inverses to each other. 3 comma 7 and 7 comma 3, and 9 comma 9, 9 into 9, 81, 81 mod 10, 1, which is congruence operator. Okay, so total 3 pairs we have from Z10, and the same way Z11. In Z11 we have 1 comma 1, 2 comma 6, like this. Okay, so because based on the value n value, based on n value, we can say that which values have multiplicative inverses. The n value is prime, then prime number, that means what are the values in the set except 0, 1, 2, 3 and so on, n minus 1, except 0, all the values contain multiplicative inverses. If n value is not a prime number, then some of the values from the set have multiplicative inverses. Okay, Zn, if n value is prime number, that means we have all the values except 0, all the values contain multiplicative inverses. So if you want to find multiplicative inverse, you need to follow extended Euclidean algorithm. In extended Euclidean algorithm, we are finding GCD and as t values. So how can you find the multiplicative inverse? How can you say whether the value has multiplicative inverse or not? If GCD is 1, then we can say that that value has multiplicative inverse. So if the GCD value is not 1, then it is not having multiplicative inverse. If GCD is 1, then it has multiplicative inverse. And what is that multiplicative inverse? So in extended Euclidean algorithm, we are finding two values, s and t. Here you need to take t. Whatever the t value is there, that is multiplicative inverse of the given value. Okay, suppose for example GCD of n comma a. So we are finding, this means we are finding GCD of a from Zn. We are finding a from Zn. Okay, so if it is equal to 1, GCD of n comma a is equal to 1, that means we have the multiplicative inverse for a. Then what is that multiplicative inverse value? In extended Euclidean algorithm, we are writing another two tables. We are finding two values s and t. Here you need to take only t table. So you can neglect the s table, you can write only t table. So if the GCD value is 1, then you need to stop the t table also. Whenever the second value is 0, then you need to stop the first table, second table and third table. Okay, if GCD value is 1, then whatever the t value is there, that will be considered as multiplicative inverse. In previous session, we have discussed extended Euclidean algorithm. In that, suppose if you take here second value is 0, then what is GCD? 2. Okay, so if GCD is 1 only, then it has multiplicative inverse. Here GCD is 2, so it does not contain multiplicative inverse. Suppose take some example. Find multiplicative inverse of 11 in Z26. So what you need to do? First of all, you need to find GCD of 26 comma 11. If it is equal to 1, then that means it has multiplicative inverse. Otherwise, there is no multiplicative inverse for 11. So how to find? You need to draw the table. This is Q, R1, R2, R. (26, 11). 11 twos 22, remainder is 4, and 11 4. 4 twos 8, remainder is 3. 4 3. 3 ones, 3 remainder is 1. 3, 1. Okay, and 1 3 is 3, remainder is 0. 1 0. So here you need to stop the process because second value is 0 and this is GCD of 26 comma 11. So 26 comma 11, GCD of 26 comma 11 is equal to 1. That means we have multiplicative inverse for 11. We have multiplicative inverse for 11. So in that case, you need to write second table. Second table. Here only T table is enough. No need to take S table. T1, T2, T. What are the initial values of T1 and T2? 0, 1. Okay. So 1, quotient is 2. 0 minus 1 into 2. Minus 2. 1 minus 2. 1 minus 2 into minus 2. Minus 4. 5. Minus 2. 5. Minus 2. Minus 5. Minus 7. 5 minus 7. 5 minus of minus 7 into 3. 7 3 is 21. 5 plus 21, 26. Minus 7, 26. So with this you need to stop this table. Whatever the T value is there, this is the T value. This is multiplicative inverse. So you need to write the positive value only, negative value. Here we get negative value. How can you convert the negative value to positive value? Minus 7. Okay, minus 7, and here the modulus value we are taking 26. So minus 7 plus 26 is equal to how much? 19. Okay, so minus 7 plus 26 is equal to 19. 19 is multiplicative inverse of 11. So the answer is 19. The set of values those contain multiplicative inverses in Zn is called Zn star. Zn star means the set of values those contain multiplicative inverses. For example, Z10 star is equal to, from Zn means 0, 1 and so on, n minus 1. Okay, so from these values, whatever the values those contain multiplicative inverses, it is called Zn star. So here Z10 star means Z10 is equal to 0, 1 and so on, 9. This is Z10. So from these values, whatever the values those contain multiplicative inverses, it is called Z10 star. For example, 1, 3, 5, 7. For example, if these values contain multiplicative inverses, then this set is called Z10 star. Suppose for example if you take Z11 star. Z11 star means 11 means it is a prime number. So it is the prime number. Whatever the values in Z11, all the values except 0, all the values those contain multiplicative inverses. So Z11 star means 1, 2, 3 and so on 10. Because of that, n value is prime number. If n value is prime, then all the values except 0 in Z11 contain multiplicative inverses. Okay, I hope you understood. If you learned something from this video, please like, share and subscribe. Thanks for watching.